I'm going to make this explanation based on two facts, the Fajan rule and the Pauli scale of electronegativity difference. So one way of determining if a bond is covalent or ionic is by considering Pauli electronegativity difference chart. And there it states that if the electronegativity difference between the non-metal and the metal, or between the two or more participating atoms, is less than 1.7, it means it is the bond is going to be covalent. If it is greater than 1.7, it's going to be ionic. So fluorine with aluminium in aluminium fluoride, is this bond ionic or covalent? So let's check the electronegativity chart. On the chart, the electronegativity of fluorine is 3.98 and aluminium is 1.61. These are the values showing their tendency to draw electrons close to themselves. Now, the electronegativity difference, let's check if it is less than 1.7 or greater than 1.7. 3.98 minus 1.61, 7 here, 3 here, 2 here, 2.9, 8 minus 1 is 7, 9 minus 6, 3, 3 minus 2, 3 minus 1, 2, so it's 2.37, which is greater than 1.7. Therefore, aluminium fluoride is ionic. Aluminium chloride now. Let's check if the bond is ionic or covalent. Chlorine has electronegativity of 3.16, aluminium 1.61. So the difference is 3.16 minus 1.61. 6 minus 1 is 5. 11 minus 6 is 5. 2 minus 1 is 1. 1.55, below 1.7. Therefore, aluminium chloride is covalent, and the structural formula should remain like that. Should remain same. Covalent. This is based on Pauli electronegativity difference. Now, let's consider Fajan's rule. So, according to Fajan's rule, as the size of cations decreases across the period and the charge on them increases across the period, the covalent character of the bonds in their molecule increases. As the size of the cation decreases across the period as their charge increases, and as the size of the anions increases, the covalent character of the bond increases. So, following this, let us now associate these cations with their electronegativity values and the anions with their electronegativity values. In fact, I have written the value for fluorine and chlorine. You see that as chlorine is a bigger atom, down the group, the size increases. The electronegativity decreases down the group. Now, let me associate these with their electronegativities. So you can see as the size of the cations keep reducing across the period, the electronegativity value keep increasing, which means the non-metallic character increases. Now, following this, let us investigate aluminium fluoride and aluminium chloride. Aluminium 3+ with chlorine 1-. You can see their electronegativity values 1.61 and 3.16. If you subtract, you see that it will be below 1.7. Not only this, another thing that contributes to this is the high charge The charge is 3 plus, meaning that aluminium is reluctant to lose 3 electrons. The reluctance to lose electron is contributing to this. And the size of chlorine being relatively bigger than the size of fluorine. As the size increases, the ability to accept electron reduces, and that is the contributing factor towards the covalent nature of aluminium chloride. I hope you got value. If you did, comment, like, and share, and subscribe to my YouTube channel.